I can. Can you?
Now I can hear you. So let's start the first topic, that is counting. In
Okay.
counting, we have permutation and combination. So do you remember something about that, or shall I start with the beginning?
I do remember, and but like so like, we can just briefly go over the formula, and maybe we can like try some questions and and that all
Okay,
stuff.
okay, all right.
Yeah.
And do you remember factorial value?
So like you asking me if I know what a factorial is?
Yeah. Do you remember
Yes.
that? Okay, all right.
Yeah, yeah. I mean,
Because
I know what a factorial is. Yes.
okay, okay. So because this permutation and combination just depend on factorial value. That is why I'm asking.
Acha, acha.
Okay, so let's start with permutation. So tell me one more thing, is afternoon time fine for you for daily? You will do regularly or on alternate days or weekend? What do you want?
I mean, it will be good if you do it regularly every day. And yeah, I mean,
Okay.
actually, afternoon would work better. But at like what time? 3 o'clock or like 2 o'clock? What's the afternoon time?
Okay, you can do it too.
Two? Yeah,
2
actually,
p.m. is
that
fine for
works.
you?
Yeah, I mean, actually, that's
Okay.
perfect because in the evening I have some more classes, so two is actually perfect.
Okay. So let's do permutation. Let N be total objects, or you can say things, in which we can have digits, letter, symbols, and are to be taken together. So then the number of arrangements using are objects out of, I'll tell you, okay, I'll explain you each and everything. Out of
Sure, sure.
n objects is said to be permutation. Means we have n total things, out of which we are taking sum. Okay, we can take in sum or out of all, so which we are denoting by r. So means permutation is just about of number of arrangements in which order matter. Okay, in
Okay.
similar, in combination we just form the groups where order doesn't matter. Like if we have digit, for example, digit
Mhm.
1, 2, 3, 4, 5, and we need to form any pin code by using 3. Okay, then number of pin codes. Okay, all possible pin codes will be permutation. Are you getting this thing?
Right, right.
Yeah. So let us understand by using an example. Like take this example also. So we have total things, or you can say total desert. We have 5. Okay, and take 3 together, which is r, because we have, like we are taking and b total objects or things in which we have desert letters and symbols, and
Hmm.
are to be taken together to form arrangements. Okay,
Hmm.
then the number of arrangement using r objects out of n is said to be permutation.
Okay.
Got it? This is
Yep.
definition. And so what we have formula like permutation is denoted by like NPR, or in some book they use this NPR also. Okay, most common symbol is this.
NPR.
Okay, most, yes,
Okay.
that is equal to factorial n over n minus r factorial. Okay, so how many pin codes can we form by using three digits out of these five? Let us find it by using this. So 5p3, take factorial 5 here, and 5 minus 3 factorial here. Okay, let us now simplify. So 5pr, sorry, 5p3, we have r is equal to 3. Let us simplify. Factorial 5 can be written as 5 into 4 into 3 into 2 into 1, you know very well. And
Hmm.
5 minus 3 factorial means factorial 2. We have, so sorry. So 60 pin codes can be formed by using 3 digits out of 5. Got it?
Okay. Okay.
And we can do it by practically by manually also. We can by taking some like some letters to form some words. Like we take like we have these four letters, and we need to form word by using any three letters. Okay, so how can we form by using three? Like a how many we can find? First of all, let us find
So
by
it's like
using four.
4 permutation 3.
Yes, 5p. Sorry, we have four
Just
only.
4.
Sorry, not five.
Yeah.
Yes, we have four, and 4p3. Like factorial 4 and 4 minus 3 factorial. We have factorial 4
Basically
over factorial 1. So factorial 1 is only 1. So we have factorial 4. That means 4 into 3 into 2 into 1
24.
and 24. Yes. So let us verify now manually, okay?
Hmm.
If we'll get 24 hours or not. Let us check it. So A, B, C, and A, B, D, and B, C, D. You can check it manually also if you want. You want it,
Hmm.
or shall
I
we
mean,
do
yeah,
the next one?
we
Yes.
can do this one manually
Yeah.
for like just them, like
Yes.
as an example. Sure.
Yeah. Okay. So you can do it self your. Not required for exam, just for like just for verification. Not required. Okay.
Well,
Yeah. In this way,
yeah.
you can find. You will also you will surely get the 24 words by using any three letters out of these four. Okay. So this is formula of permutation, or you can say arrangement, number of arrangements. Shall we do the
Hmm.
next combination?
Uh, yeah, sure.
If you want to do some more question, then you can tell me, okay? Otherwise, we'll do the next. What do you
Okay.
say?
I mean, we can do questions because so
Okay,
like after we like also understand combinations. Uh,
sure. Do you have your own question, or shall I use my own?
I mean, like you can use your like own questions for now, and then I can also give some questions. I mean, I can, if you want, I can just search some wait, like let me just search some questions online,
Okay,
like permutation, eight, mathematics. Sure.
okay, I'm telling you. Just give me a moment. I'm just opening the questions.
Yes, so I found some questions on like permutation and combinations.
Yeah. So let us do one question. How many five-digit telephone numbers can be constructed using the digits 0 to 9? So we have digits 0 to 9. We have 10 digits, obviously.
Mhm.
Okay, and we need to form or construct telephone numbers by using five digits. So here N is 10, R is 5. I'll give you this question on WhatsApp also. And we need to find
Okay.
total number of, yeah. So let us find it. Just put in formula 10p5. Just you need to simplify by using this formula, or trick of shortcut trick of this factorial value. Do you remember that?
Sorry, factorial value.
Um, I'm asking shortcut trick of this factorial value, because we'll expand till here only because we have factorial 5 in
Okay, okay,
denominator.
okay,
So just
okay.
cut it. Okay, so you will get this 10 into 9 into 8 into 7 into 6. Okay, so just calculate it and you will find the number of telephone. Got it?
Yep, yep.
Okay. Okay, now I'm telling you the formula of when repetition is not allowed and allow, and let us do for that, and then uh, just a minute. Okay, now we are going to learn when we have repeated things or repeated objects. Okay,
Mhm.
let us know. Just a second. Hmm. And we have few more formulas of permutation for different conditions. First, number of permutation of n objects if repetition is not allowed is not allowed. I'll tell you by using example also. Uh, like by using this formula. Okay, we can find the
Mhm.
permutation of n objects, means we are taking all together. Okay, we are taking
Okay.
here all together, not
Hmm.
only r, means r is equal to n. Then how?
Hmm.
Then we need to find permutation. So this is
Okay.
number of permutation here, and this formula you know very well, and up to 3 into 2 into 1. Okay, so this is first formula when we are taking all together. Now, number of permutation of r objects from n if repetition allow. Okay, repetition allow. So we have the formula like n into n into n, n r times, means we are repeating n r times. Okay, then it can be
Hmm.
equal to n to the power r. How? Take an example, means using digits 1 2 3 4 form 3 4, and take one more 5. How many pin code can be generated? We need to find it. So how many 4 digits, sorry, how many 4 digit pin codes can be generated?
Hmm.
So we need to form 4 digit pin code. So obviously we have 4 places. Okay, here repetition is allowed. So obviously this place can be filled by using all of 5 digits. Are
Hmm.
you getting this?
Yeah.
So similarly, this can be also filled by using all 5, and this also. Okay.
Hmm.
So number of permutation is equal to 5 into 5 into 5 into 5. Obviously 5 to the power 4. By using this formula, we can find directly. Okay.
Okay. Okay.
So if repetition is allowed, then you can find by using this formula directly. Got it?
Right. Right. I've done like 5 factorial.
No, this is not equal to 5 factorial. This is 5 to the power 4.
No, no,
This
like
is different.
I'm saying like
Yeah.
in the case that like if it was not allowed, like yeah,
Yes, exactly.
then
Yeah.
you would have done 5 factorial, right?
Yes,
Okay.
exactly. Okay, so let us do the next topic. When different things or different objects repeated. Okay, let us do. Just a second. Now condition is number of of different permutation, or you can say number of permutation simply, of n objects where where n1 repeated items, n2 repeated items. I'll tell you by giving examples also.
Mm-hmm.
And up to nk repeated items, or you can say objects. So then we have number of permutation is equal to, we have formula factorial n, because we are finding this. Okay, this is formula for that number of permutation of n objects. Okay, so we have
Mm-hmm.
formula n1 factorial into n2 factorial up to nk factorial we have. Okay, if we have repeated items. Okay, and you can
Okay.
understand by using an example. Just a second, I'm giving you one example. Sometimes they give like any word in which we have repeated letters. So see, we have word, for example, we have word mathematics. Okay, so let us see which letters are repeated. So first of all, write down total letters in mathematics, which is n. Okay, let's see, 4 and again 4. We have 11, right? Now, total M in the word, in the given word. How many we have two? Obviously, we have two. Here we are talking about only repeated. Okay. And also A in the given word. We have also two. And again, T. Are you getting these steps or shall I explain you again?
No, yeah, I'm getting these. I'm getting these.
So M repeated and A repeated and T also and
Yes,
other are
that's right.
different, right?
Yeah.
Yeah. So now let us find the number of permutation. Or simply you can say permutation. You can write this also, okay? Out in a sheet of number of permutation, simply write the number of permutation or permutation
Okay.
is equal to means here in denominator we'll write here repeated, okay? How many times the objects repeated, okay? So here let us take the total, which is 11 factorial.
Uh-huh.
Now 2
Uh-huh.
factorial into 2 factorial into 2 factorial because we have these three repeated. Okay. Now let us simplify, then you can get the total number of permutation. Okay. Or total number of words can be formed by using these letters. Okay.
And
Question is
so,
that, yeah,
I'm
tell.
so like basically what this like question means, like the answer will be the number of ways we can arrange this
Yeah.
word, uh,
How many words can
so
be
that
formed,
these. Uh,
can be can be formed by using letters of giving word
okay.
of uh, okay, here whiteboard is not allowed. Okay, I'm just writing it on previous. I'm writing here. How many? This is question. Word can be formed by using letters of word mathematics. Now got it?
Permutation.
So yeah,
No, no. I think we are not right. Like just the words, just these words.
actually whiteboard is not allowed on right side word mathematics. Are you getting this now?
Yes, yes.
How many words can be formed by using letters of word mathematics? So we need to just we use this formula for repeated letters. We'll use in this form just dividing by factorial value of all of these to the total factorial value of total. Okay.
Right, right.
Shall we do some more questions or it is enough? Shall we do some more?
I mean, we can do one more.
Okay.
So like which look like
Yeah.
these. I found some. So like the number of three digit numbers such that the digit one is never to the immediate right of two.
You can send me your questions, okay, to me so that we can do.
Just one
Okay.
second. Should I
Just send me.
WhatsApp you?
Sure, sure, you can.
So I just sent you a PDF file. It has some
Okay,
questions for like permutations and combinations.
sure.
And I was asking for, I mean, like any question out of that, but like question number three. Uh, yes.
Okay, three number of three-digit number. Okay, such that one is never to immediate. Okay, right of two is. Okay, so that digit one is never to immediate right of two. So first of all, we need to find all permutation, all possible. Okay, then we'll see what will we do the next. First of all, you will find for all of these, and after that, just subtract. Two conditions. Like we need to form three-digit number, and we have two conditions. You know, if we write two here, right? Then we
Mhm.
cannot write one here. Okay? Are you getting this thing? They are saying that number three-digit numbers, like three-digit numbers, such that one is never to immediate right of two.
Up to. Yeah.
Okay?
Mhm.
Yeah. So how can we find them? So we need to just subtract all those numbers from the total which we have just right of me having the same condition. Okay, like this place can in this condition we have two more condition because we if we write two here we can't write here one. Okay, and if we write two here
Right.
then we can't write one here. Okay, so we have two such cases. So just we'll find for that and just subtract from the total. Then in this way you can find that is not for that. Just by using just opposite condition. Are you getting this thing?
Yes. Yes.
Okay. So in this condition, this place can be filled because we have three. So that one can never. Okay. So this place can be filled by using all 10 digits. Okay, because they are not specify the digit which digit. Okay, so
Right.
obviously we are taking all, so this place can be filled by 10 ways.
Mhm.
Okay, and this place only filled by 2, only one way. Are you getting this thing?
Mhm. Yep.
And this, yeah, and this place can be filled by only one, so only one way. Similarly, here this place can be filled by 10, only 9 ways. You know why? Because we can't include 0 at this place to form three-digit number. Are you
Right.
getting this?
Right.
So this place can be filled by 9 ways. And if we take here 2, then obviously we have only one way, and this also we have only one way. Okay, so just subtract like from all. Yeah, like we have here 10 ways, 10 all possible numbers, and here we have 9. Okay, then we can subtract from all. Are
Mhm.
you getting this? Or like,
Mhm.
sorry, just find all possible permutation by using 10 and C. And remember one more thing is that because we just to find all. Okay, this place can be filled by only 9 ways, and this can place I mean filled by 10, and this also filled by 10. So
Mhm.
after multiplying these all, you can find all possible numbers. Okay,
Mm-hmm.
So you have total numbers is equal to 9 into 10 into 10, 900. And now for given condition, we need to subtract these both conditions. Are you getting this point? Are you getting
Uh,
this point?
yes, yes, yes.
Yeah. So required numbers, required total numbers we are finding, because according to condition we are talking about this. Required total numbers is equal to 900 minus 10 minus 9. Okay, 881. Got it? Are you getting?
Mm, yeah, I actually got it. Yes. Yeah, of course, cause
So
like the question
you
is,
got you got these two conditions. Why we are taking these?
yeah, yeah. I mean, of course, cause the question says that like we like only have to consider the questions
Yes.
like the numbers two
Yes.
and one. We have to, cause like
Yes.
that's what the
So
question asks.
yes. So first of all, we need to find all numbers having this condition or having this condition. Okay, and just subtract them from the total. So obviously we'll get those numbers which are not including this condition. Are you getting this now?
Okay, okay.
You got it, or shall I repeat it?
So yeah, I got this one. I got this one.
Yeah. So here we have 10 such numbers have this condition. Means just one immediate right to 2. We have 10 numbers such in first condition. Okay. And in second condition, we have 9 numbers. So just subtract these 90 numbers from the total, then we'll get this total numbers required, in which we don't have this condition that one immediate after right side of 2. Okay.
Yep. Yep.
Yes. So you can practice that. And so you are going to do tomorrow also, right?
Yeah, yeah, sure.
Okay, so you will do each day, right? If you are sure to take, then only tell, because we I have another class on weekdays. That is why I'm asking.
Hello.
Okay. Yeah, I'm saying that if you are sure to take regular classes on all days
Uh-huh.
of week,
Uh-huh.
then you can confirm me so that I can arrange time for you, because I have another classes. So that is why I need to arrange the time.
Okay, okay, okay.
Okay.
Uh, yeah, ma'am. Like, so, like, this was the class for like probable permutations and combinations,
Yeah, we have done
right?
already only
Only so.
permutation. Yes. And in next class, because I have another class at 7 p.m., but we couldn't
Okay.
start on time. So they are waiting. That is why. We'll do little bit extra in next class. Okay. As we
Hmm.
have done less today. That is why, but I need to start the next class. That is why now we should leave. Okay.
Yeah.
If you
What
are
I'm
sure to
thinking,
take tomorrow, so that
right?
I can arrange time for you. Yeah, tell me.
I was saying that, man, like the things that I'm thinking, cause like I've course which like does cover like all the topics in syllabus, and the things that like I could like watch the lectures there and then like practice some questions with you. So I think that would be a good option for me. uh,
Okay, so what do you want? Do you want regularly or on alternate days or only weekends? What do you say?
i I think like weekend classes would be good. I could do that, yeah.
Okay,
Like I could like study for all week and then like find some
sure, sure. You can. So,
struggle with,
will you
and
do
then like
tomorrow also,
study.
or only one class is enough for you?
Ma'am, I think that I will like like try to study some lectures and like find some questions that I struggle with, and
Sure,
like then I like contact you in a few days. I mean, I guess
sure.
I'll just I mean probably next week or even like 4 5 days.
Okay, okay, sure. You can.
So I think yeah, like that would be better. Like we can like regularly have 1 2 classes each weekend
Sure, sure, sure. You
for
can.
doubt
Okay, all
solving.
right. Sure, sure. That would be good.
Okay, ma'am.
Okay.